Hello everyone. Today we are going to study about the Pandas libraries in Python. So what is Pandas and why we use it? It is a data manipulation and analysis library based on Python. This library offers many options and easy methods to manipulate and analyze data. So we can use this library for loading CSV file, Excel file, or JSON file, or different formats of file, and use it to manipulate and analyze that data, like handling missing value, filtering the data, grouping the data. Those kind of things can be easily done using this library. So Pandas has primarily two data structures, series and data frame, which allows for easy data manipulation and analysis of tabular data. So first we need to install this library. So to install Pandas, we can use pip command, or if you are using conda environment, then you can use conda command. Here if you are using Colab environment like myself, then you can use this pip install pandas command directly here. So if you run it, it will install the library for you. So I had already installed the library, so it is showing that requirement already satisfied. So if you haven't installed it, it will automatically install it for you. After installing it, you have to import the library. Import pandas as pd. This is the command to import the library. Now let's dive deeper into the series and data frame in pandas. Series. So series is a one-dimensional array-like object capable of holding data of any type, like integer, string, floating point, numbers, Python objects, etc. It consists of sequence of values along with associated array labels or index. So each value will have a corresponding index. So you can think of a series as a single column of data. So characteristic of series. So characteristic of series are homogeneity. All elements in series are of the same data type, and the size of the series cannot be changed once it is created, and each element will have a corresponding index, and it is almost similar to numpy array. In fact, it is built on top of numpy arrays. So many numpy functions can be easily applied to this uh, pandas series. So now we will see how to create a series in pandas. So we can use pd.series method by passing a list or array or dictionary to it and create a pandas series. Let's say we want to create a series for using a list, so you can pass this list 1 2 3 4 5 inside pd.series function and assign it to a series called s1. Then it will automatically create the series for you. So if you run it, you can see that it has created a series 1 2 3 4 5 with the index 0 1 2 3 4 5. So you can pass a dictionary also to create the series. So let's say we have a dictionary called data with this key and value pairs, and if you pass this dictionary to pd.series function, it will create a series where keys are taken as the index and values are taken as the column values. So in essence, a single column of data frame is known as a series. So you can assign row labels to the series the same way as before using index parameter. So if you want to use row labels, or instead of direct or default index, you can use it like this. Here pd series function, we are passing a list, and we are passing a list of index names like 2015 cells, 2016 cells, 2017 cells. And also we can pass the name of the series as per our requirement. Let's say we are giving the name here as product A. So if you run it, it will give you 2015 cells as 30, 2016 cell 35, like that. So instead of default index, it will take the index values from this list, and name will be taken as the name given here. Now coming to the most important part of the pandas library, that is called data frame. So it is a two-dimensional label data structure with columns of different data types. It is analogous to spreadsheet or a SQL table or a simple table in Excel. So characteristic of a data frame, so it has tabular structure. We already explained that it has rows and columns just like table, and we can index this data frame using the column. That means we can access the columns by directly using their names. How can you do that? I will show you in the later part of this video. And heterogeneous data, so each column in the data frame can have different data types. So one column have integer data type, one column have uh, string data type. So different kinds of data frame, it different kinds of data types it can have. Size is mutable, so unlike series you can modify the size, so add or delete rows and columns of data frame easily. Now how to create a data frame using pd.dataframe method. So you can pass a dictionary and create a data frame easily using this pd.dataframe function. So here I have created a dictionary. Here name is given and age is given. So if you pass the dictionary to inside this function and assign it to df1, and if you run it, so you can see that it has created a data frame with column name and age, and all the values are given here for name and age has these values. Now you can also pass a list of dictionaries to this period data frame function and also create a data frame. So here you can see that I have passed a dictionary or name John age 28, name Anna age 35. So this is a list of dictionaries. So if you run the data frame function over this, it will create a data frame with column name and age, and all the values will be given here, and automatically it will be indexed. Similarly, you can use numpy arrays to also to create a series. So if you pass a numpy array inside the period data frame function, and it will create a data frame for you. You can also define the column names as, let's say we are defining the column names here as A, B, C. So if you pass this or if you run this, it will create a data frame for you with column A, B, C, and each row will have the value from this list. So 1, 2, 3 as the first row, 4, 5, 6 as the second row. Similarly, you can use different kinds of dictionary structure and list structure to create a data frame. So here you are using a dictionary where Bob said this kind of things and Sue said this kind of things. So here we are passing this dictionary and it has created this data frame with Bob and Sue as the column and what were said by them as their rows here in the row values. So like that, we can use different kind of methodologies to create a data frame from scratch. But in real life, the data frames are generally not created manually. We can load CSV file and Excel file from outer resource or our personal database and load it using Pandas, and it will automatically convert that data set into Pandas data frame. Then you can run other operation on it. So data coming to the data frame attributes. So data frame has different attributes. Most important attributes are dot shape, which returns the tuple representing dimension of the data frame, number of rows and number of columns. Dot d types returns the data types of each column in the data frame. Dot index returns the index of the data frame. Dot columns returns the column names of the data frame. And there is a function called dot head which will give you the first few rows of the data frame. By default it shows five first 5 rows of the data frame, and the tail function you returns the last few rows of the data frame. By default it returns the last 5 rows. And another important function is called an unique. An unique will show you the number of unique values in each column, and value counts function returns a series containing counts of unique values in a column sorted in descending order. So if you use this function, you can use this like here. Let's now you see the use of these functions. So if you want to see the first 5 rows like this, you can show using this head functionality. If you want to know the column names, so here you can see the column names are shown here. If you want to know the shape, df1.shape. If you want to know the data type, df1.dtypes. And if you want to know the index, it will show you the df1.index. If you run it, So it's showing the same as 4 rows, 2 columns, and column names and the data types here. df1 data types, for this it is showing there. And for index, it is showing the output as range of index is starting from 0 and index is stopping at 4, and gap between each index is as shown as step equal to 1. And if you want to know the information about the data frame, you can use df1.info function, which will show you the basic information about the data frame. Here you can see that it will show you the column names, what are the total number of columns, and how many non-null values are there in the data each column, and what are the data types of each column, what is the memory uses of the data frame, it is also showing here. You can use the df1.describe function to show the numerical columns summary like count, mean, standard deviation, minimum value, maximum value, 25th percentile, 50th percentile, 75th percentile, like this here. Now if you run it, by default it will show you the description or the statistics of the numerical column only. If you want to know the all numerical plus non-numeric column like details, you can use this option called include equal to all inside this describe function. It will show you all the columns details irrespective of its data type. Here you can see the age column is numeric column, so it has all the mean, standard deviation, minimum value, maximum value, like that. But the name column doesn't have these values because it is non-numeric. It will show you the count and unique value and what is the top value and what is the frequency. So those kind of statistics it will show. So you can, using these different kinds of option, we can see basic information about the dataset we are using or we are loading using Pandas. So in the next video, we will discuss about how to read a CSV file using Pandas library and other kinds of file using Pandas library. Thank you.